Dear students, let us discuss about the chapter of solids. In this chapter you have studied what is space lattice, unit cell, the number of effective particles in a unit cell. Then unit cell is basically the smallest portion which when repeated over and over again gives rise to the whole lattice. Now the questions which are generally asked in this case is, okay, here is a simple unit cell which has the points on the corner as well as on the faces. You know, a corner is being occupied by 8 other unit cells, so its effective contribution is 1/8. A face is shared by 2, so its effective contribution is half. A body, it is a part of the unit cell, its contribution is whole. The particles which are present on the edges, their contribution, dear students, is only 1/4 because it is present in 4 other unit cells. Let us take a question. If radius of sodium ion is 97 picometer and that of chloride is 181 picometer, then what will be the edge length of the unit cell? You have studied sodium chloride is rock salt type. In this case, chloride is on the corners, sodium on the edges, chloride on the faces, and sodium in the body. Now since chloride is on the corners, then its contribution will be 1/8. Now if we take the edge length, the whole edge length is equal to twice that of sodium ions plus chloride ions, which is equal to 97 plus 181 into 2, which will be the edge length. So you can find out now the total edge length will be equal to 8 plus 9, 17 plus 2 into 2. So 2 into 2, 78, that is to say 556 picometer. In the same way, let us take another question. A solid is made up of A cations, An plus, and oxide anions. Oxide forms cubic closed packed structure. If An plus occupies all the tetrahedral voids, then the value of N is. In this case, first thing you should know is the crystal is always neutral, whatever may be the defect in it. Since oxide forms cubic closed packed structure, it means the number of oxide ions in this case is 4. Now A is present in the tetrahedral voids. For each point, the number of tetrahedral void is twice the number of spheres. It means number of tetrahedral void is 8. So A will be equal to 8. Crystal is neutral, hence 8N is equal to 8, N is equal to 1, so its oxidation state is equal to 1. Another question. Nickel oxide has the formula Ni 0.90. The fraction of nickel that exists as nickel 2 plus and nickel 3 plus ion is. Again you keep it in mind, the crystal is always neutral. Let us say nickel 2 plus is X. Then nickel 3 plus will be 0.9 minus X. As crystal is neutral, so 2X plus 3 into 0.9 minus X will be equal to total negative charge. And on solving, you will find that the answer comes out to be 7:2. Again, let us take another question. A is present on the corner as well as in the body. The crystal will be. Dear students, the point which is present on the corner, if it is present in the body, then only it is body centered cubic. Otherwise, it will be a simple cubic. You have taken the example of cesium chloride in your books. There chloride is present on the corners, cesium in the body. It is a simple cubic which is wrongly named as body centered cubic. The body centered cubic must have the same points in the body which is present on the corner. Now another topic in this case is the defects, and there are 2 types of defects: stoichiometric defects and non-stoichiometric defects. Stoichiometric defects are those in which the ratio of cation to anion is the same as indicated by the formula. These are basically from within, nothing is added from outside. In the case of non-stoichiometric defects, the ratio of cation to anion is not the same. This may be due to metal excess or metal deficiency. It may be intrinsic, means that metal is showing different oxidation state, or it may be extrinsic, you are adding impurity from outside. Let us take an example of this. If sodium chloride is doped with 0.2 mole % aluminium chloride, then the number of voids created will be, you see, the valency of aluminium is 3. So each aluminium added will displace 3 sodium ions. Hence each aluminium will create 2 voids. You have added 0.2 mole percent, means 0.2 upon 100 moles of aluminium has been added. Each aluminium creates 2 voids. So the total number of voids will be equal to 0.2 into 2 upon 100 into Avogadro's number, which will come out to be 4 into 10 to the power minus 3. Now again another question. If sodium chloride crystal is prepared in the presence of sodium vapors, then which of the following is true? When you are preparing a crystal in the presence of sodium vapors, certain sodium atoms will condense on the surface. As a result, there are certain anionic sites which will be occupied by the electron. Since electron is present, so it will be colored because of the presence of the electron. Again, electron is mobile, so it will conduct electricity also. Next, since electron is unpaired, it will be paramagnetic also. Hence all these properties will be present in this crystal. As a result, the correct answer will be